Today's lesson. We're going to be talking about parallel and perpendicular lines in just a few minutes. But first, let's solve a few review problems. On our first sample here, we're asked to solve the equation for y and state the slope and the y-intercept. So we know that the first step is to rearrange, move the 7x over to the other side behind the equal sign. Our new equation will look like this: 3y equals negative 7x minus 21. Then our last step to simplify will be to divide by 3, and we will be putting it in slope-intercept form. So our first part of the equation will be simplified to just y. Then we'll have a slope of negative 7/3. Don't forget the x next. And then negative 21 divided by 3 is negative 7. So that is our equation in slope-intercept form. All right, for number 2, it says write the equation of this line. So in order to do this, we need to know the y-intercept, which is b. And we also need to know the slope, which we call m. And then we'll just write the equation. Well, as we look at our line, we notice that it crosses the y-axis right here at the point 0, 2. So that makes the y-intercept 2. And if we notice also, we all have the slope depicted here, so it has a slope of up 3 over 1, 3 over 1. So now we can write our equation. Y equals 3 over 1x plus 2. And oftentimes you'll see this written also like this: y equals just 3x plus 2, because they basically simplify this fraction 3 over 1 into just 3. All right, so for our last example, find the slope between the 2 points. We keep doing these because we want you to know how to do this. So we're going to do y2, which is 2, minus y1, which is negative 7. And 2 subtract negative 7 is 9. That's our change in the x direction. Then to go from 4 to 4 in the y direction, negative 7 to 2 in the y direction. Then from 4 to 4 in the x direction, that sounds kind of fishy. 4 minus 4 equals 0. Oh, whenever we have a 0 in our slope, that's a special situation, and we call that undefined, because this would be a vertical line going straight up and down. So undefined. All right, let's move on. So when we talk about parallel lines, in order to tell if they're parallel, there's something very characteristic about their slope. And that is that they're parallel or they have the same slope. So if we look at this first line, we notice that it's in y equals mx plus b form, so the slope is 5. So when we're asked the question, what would be the slope of a line that is parallel to this line, we just basically write the same number. If we had another line that had a slope of 5, it would be parallel to this line. So that's pretty straightforward, isn't it? Let's try a couple more. Find the slopes of a line parallel to the given line. Okay, the slope of this line is negative 1/3. So something parallel to that would be negative 1/3. What about this one? It has a slope of 3/7. So the slope that would be parallel to that would be 3/7. All right, that's pretty good. Now, we haven't asked you to write an equation of a line. We just asked you to write what the slope would be. On this next one, we notice that we have y equals 4. If we look at where that is on the coordinate system, 1, 2, 3, 4, we notice that we actually have a flat line that passes through at just 4. And whenever we have a flat line like that, we have a 0 slope. So this slope, this line or one parallel to this would have to have 0 slope to be parallel. For example, this next line could pass through it too. It also has a zero slope, and that makes those two parallel. All right. So now let's talk about perpendicular lines. Perpendicular lines do not have the same slope. In fact, they cross each other at 90-degree angles. So their intersection creates four 90-degree angles like this. And so it turns out that there's two very characteristic things about these slopes if they're perpendicular. The numerical value of their slopes are negative inverses of each other. So inverse means to flip it upside down. So let's look at this first one. A perpendicular slope to this one would be 3 over 2, so it's an inverse of it, but it also has to be the negative version of that. So we put a negative sign in front. So this slope right here would be perpendicular to a slope of 2/3. Well, how about a slope of negative 4 over 1? Well, flip it upside down, 1 over 4. And instead of negative 4, it's got to be the opposite, the negative of negative 4, which makes it a positive 4. So a positive 1/4 slope would be perpendicular to this slope. And then for 4/5, flip it upside down to get the inverse, so that would be 5/4. And if it's a positive here, and we make it the opposite of that, or the negative of that, it becomes negative 5/4. So that's the perpendicular slope to the first one. Okay, so a horizontal line and a vertical line are always perpendicular. That's something to know. So when we have a coordinate system, we know that the x-axis right here and the y-axis are perpendicular to each other. Okay, so let's take a look at these. You find the slope of a line perpendicular to the given line. So if this has a slope of 2/3, the perpendicular slope would be 3/2 with a negative sign in front. This next one has a slope of 4/5, so the perpendicular slope would be 5/4, and the negative sign that's in front is turned into a positive. This one has a slope of 7 over 1, so the perpendicular slope would be negative 1 over 7. And our last one has a slope of negative 3 over 1. So to make that a perpendicular slope, we flip it upside down, we'd have 1 over 3, and instead of negative, it would be positive. So there's our four perpendicular slopes to the original slopes we were given in each of those problems. Okay, now let's find the slope of a line of each of these two lines and determine if they are parallel or perpendicular. That means we're going to check their slopes and see if they're the same. If they're the same, they're parallel. If they're negative inverses, then they'll be perpendicular. Or if it doesn't fit into either category, we would say neither. So let's try it out. So we're going to start out by doing 1 minus negative 3, or y2 minus y1 in the first equation, and 6 minus 5 on the bottom. That's the change in x. So 1 minus negative 3 equals 4, and 6 minus 5 is 1. So this has a slope of 4 over 1. Take a look at the second one. There's y2 is negative 11. Subtract y1, so subtract negative 3. So negative 11 minus negative 3 is equal to negative 8. Then we have 5 minus 2 on the bottom, or excuse me, 5 minus 7. x2 minus x1 is 5 minus 7, so that equals negative 2. And when we simplify this, the negatives go away, and 8 divided by 2 is 4. So this turns out to be positive 4 over 1. So we notice that these two slopes are the same. And if they are the same, that means they are parallel lines. All right, that was pretty easy, wasn't it? Okay, so we have a little worksheet for you on parallel and perpendicular slopes. several problems of each type to try out. So good luck and thank you very much.